projectile motion. Projectile motion is just an application of the Suvat equations that we've seen beforehand. But it comes in two varieties. One, a lot easier than the other to solve, but we'll talk about them both in this video. So the first, the simpler motion, is when we've got a 1d initial velocity and a 1d acceleration perpendicular to the velocity initially. Okay, so this is where focus is a bit off. So this is where we're starting. So we've got 1d initial velocity and a 1d acceleration, which is perpendicular to the velocity initially. Alright, that might not mean much, but basically what it means is that we have got, if this is our table, and if we push a ball off here, then it's got an initial velocity, so u in this case equals, I don't know, 5 meters per second. And then our acceleration, the acceleration that we have is going to be gravity, so 9.81 meters per second squared. We'll try and do it in the correct format. So we've got a velocity going horizontally, we've got an acceleration going down. 1d initial velocity, 1d acceleration, initially perpendicular. Now, the classic question for this is how far from the table does the ball drop? Well, we need some more information for that. We need to know the height of this table. So the height of this table is going to be 0.8 meters. And that's the only other information that we need. So going down our thing, so we are trying to find, we are calculate how far the ball drops off the table. Okay, so calculate how far the ball drops off the table. That's what we want to do. So, following our 10 steps, 1, we're not going to panic, we know what we're doing. Step 2, we read the question. So we've got a ball that's 5 meters, ball that's 0.8 meters off the floor is pushed forward at 5 meters, acceleration is 9.81 meters per second squared, and we want to know how far the ball drops off the table. Okay, step 2, let's list what we know. Now, with all Suvat, with all projectile motion, vertical and horizontal don't affect each other. So we can list them as one. So we can put our x direction. So if we define x as going that way and y as going that way, by making y going down just means we avoid negative numbers. So we have our x, we have our y, we have our x uvat, choose a little x, a, u, v and t. This is why I don't like using x, I much rather use s because it gets confusing when we talk about x and y direction, but we'll be alright. So this is what we want to calculate. How far we go in the x direction is what we want to calculate. How far we go in the y direction is 0.8 meters. We know that, that's how high the table is. Acceleration. Now, all these questions will have no air resistance, so acceleration in the x direction is 0. Acceleration in the y direction is 9.81. The initial speed here is 5 meters per second, and for y we're going horizontal, so it's 0. The final speed for both we don't know. And the time, again, we don't know time. but this is important. And time's not a vector, so these two times are the same. Time's global effect. That's the only thing that affects both. Okay, so if we look down our x, we've got 1, 2, 3 unknowns, only two things we know, so we can't do a lot at the minute with the x. However, with y, we know 1, 2, 3, and we want to calculate a fourth. We've got our four things. If we look at our equations, all four of them have got only 4 terms in them, so we're going to pick the one that's got those 4 terms. So we've got x, we've got a, we've got u, we want to know t, so we select our equation with x, u, t, and an a in it, and so it's that equation. So our first step, step 1, is going to be calculate the time. So we select our equation, x equals ut plus a half a t squared. Groovy, we know what we're doing with that. Okay, now we've already said that u in this direction is 0. So this actually is 0, so we get x equals a half a t squared, because 0 times anything is 0, we can get rid of it. So we've gone from having a quadratic equation, which will be quite tricky, to now, okay, it's still got t squared in it, but it's a lot simpler to solve. So we've got 2x divided by a. So what I've done to get from there to there is I've times both sides by 2, and then I've divided both sides by a, and so I've got that equals t squared. Then I square root both sides, so I'll get 2x divided by a, all square rooted, equals t. I now substitute in, so t equals the square root of 2 times 0.8 divided by 9.81, which gives me a value of, let's just load up the calculator again, the square root, and I'll put it in brackets just to make life easier, 2 times 0.8 over 9.81. So that gives me a time of 0.4039 seconds. Now, because this is a multi-step equation, what we're going to do is we're going to store that in the memory. That time, we're going to store that in the memory, so we know we've got it if we need it for later on. Well, we are going to need it. Right. So, step 2, we'll do step 2 down here. Step 2 is now going to be find the range. Now range generally means the displacement in the x direction. And the horizontal direction. Okay. So I now know I can, in fact I can put my time back in here, 0.4039 seconds. So I've now got, I want to find x, and I've got 1, 2, 3, 4. So I look back at my equations. I've got x, I've got u, I've got t. In fact, I can use exactly the same equation again. X equals ut plus a half at squared. So x equals ut plus a half at squared. That's the equation I'm going to do, but this time a equals 0. So that bit there goes to 0, so I'll get x equals ut. It's going to be 5 times 0.4039. So on our calculator, we're going to actually do our answer times by 5. So we could have got away without storing it. By storing it just means if it switches off or whatever, we keep it in there. So we've now got that is 2.0192751,094 meters. Now we're not going to give our answer to that. We've got to go back to our question. We check our significant figures. We've probably got 1, 1. This is to 3. So we'll probably go roughly in the questions. Probably go to 2, 2.0 meters. Remember, the 0.0 implies that we're to two significant figures. By writing down the whole answer, we'd get most of the marks. We might lose one for our rounding error if we got there. Okay, so that is the simpler motion, and we'll finish it there.